students, I hope all of you are doing good. Let's start today's chapter, Algebraic Expressions. Introduction. Let us observe the following. See, 1 dot, 2 dot, 3 dots and so many dots. Similarly, 1 apple, 2 apples, 3 apples and so many apples. So in figure 1 and figure 2, the first 3 boxes are representing 1, 2 and 3 and the last boxes are representing so many. For this so many, we use letters like X, Y, Z, etc. Okay. So to generalize something, we use such letters. Okay. Use of letters to represent numbers. Let us consider the following cases. Number 1, in arithmetic, we have 5 into 0, 0, 7 into 0 is equals to 0. Okay, and so on. In other words, any number multiplied by 0 is 0. This arithmetical statement can be rewritten by using a letter A, means A into 0 is equals to 0. Okay, so where A represents any number. Okay, so any number into 0 is equals to 0. 2. Further in arithmetic, we have 1 into 6 is equals to 6. 1 into 8 is equals to 8 and 1 into 20 is equals to 20 and so on. That is, multiplication of 1 and any number is equals to the same number. Okay, so this arithmetical statement can be written as a letter A as follows: 1 into A is equals to A. Third, let us consider the perimeter of a square of side 4 units. So perimeter is the sum of all sides, so we can represent perimeter as P and side as S. So P is equals to S plus S plus S plus S is equals to 4 into S. So from the above discussion, we know that we use of letters to represent number helps to think in more general terms. These letters are generally known as literals. Okay, literals. The letters which are used to represent or replace numbers are known as literal numbers or simply literals. Okay. Number 2, constants. The numbers which we used, that is numerals, are constant or also called dependent values or fixed values. Example, 1, 2, 3, minus 5, half, etc. Variables. The letters which we use as variables or independent values, that is X, Y, Z, A, B, C. Okay. And terms. The product of numerals and literals together is called term. For example, 2xy, this is a term. Minus half x square y, this is a term. Okay. Like and unlike terms. Like terms. The terms having same literal factors are called like or similar terms. Example, 3y square minus 15y square, 82y square and minus 11y square. Unlike terms, the terms not having same literal factors are unlike terms. For example, as you can see, these are unlike terms. Constant terms. A term of the expression having no literal factor is called a constant term. Example, in the expression 3x plus 4, 4 is the constant term. 3x plus 4, this is the constant. Okay, and in the expression 2x minus 4xy plus 6, the constant term is what? 6, right? Coefficients and factors. Consider an expression 9xyz. Here 9x, y and z are called the factors of the given expression. X, y and z are called literal factors while 9 is called a numerical factor. In 9xyz, any one of the factors is called the coefficient of the product of the remaining factors. This 9 is the coefficient of xyz. Okay, and x is coefficient of C, 9xy, C. X is the coefficient of 9yz. Okay, then y is coefficient of nxz and z is coefficient of nxy. Right? Properties of literals. Since literals are used to represent numbers, they must obey all rules regarding the operation of addition, subtraction, multiplication and division of numbers, right? So we have the following notations and rules. Number 1, the sum of two literals numbers x and y is denoted by, see, we have two literals and sum of these two literals is x plus y. Okay. 2, if the literal number y is subtracted from the literal number x, we denote the difference as x minus y. 3. The product of two literals x and y is written as x into y, or you can also write xy. Okay. 4. The repeated product of a literal number x with itself is written in the exponential form. For example, x into x into x into x is x raised to the power 4. Okay, here x is multiplied 5 times, so we will write x raised to the power 5, right? 5. If the literal number x is to be divided by y, that shouldn't be equal to 0, we write x by y or x slash y, right? 6. X plus y, you know, x plus y is equals to y plus x. If we change the order, okay, the sum remains same. Okay, xy, we can also write xy as yx. Okay, next is x plus y plus z is equals to x plus then y plus z. Okay, and 9, x then in bracket x plus z is equals to xy plus xz, and next is x plus y into z is equals to xz plus yz, and 11, x into y into z is equals to x into y then into z. Now let us consider some examples to consider the above rules. Okay, so let's check out example 1. 6 more than a number x, x plus 6, y less than 8. Okay, 1/5 of the sum of x and y, sum of x and y, and then 1/5. Okay. 4. 7 less than the quotient of x and y, means x divided by y. Okay, and 7 less than means minus 7. Next, 5. Quotient of x and y added to the product of x and y. Quotient of x and y added to the product of xy, right? Next, 18 taken away from the product of x and y. Okay, 18 taken away, that is minus 18, taken away from the product of x and y, that is xy minus 18. Next, algebraic expressions. We have come across expressions of the type x, 6 plus x, xy minus z minus x raised to the power 5, etc. So all these are called algebraic expression. An algebraic expression is combination of numbers, literals, and arithmetical operations. One or more signs, that is plus or negative, separate an expression into several parts, and each part is called a term of the expression. Okay, when an algebraic expression consists of only one term, it is called a monomial. For example, these are all monomials. An algebraic expression containing two unlike terms is called a binomial. For example, all these terms are binomial. An algebraic expression containing three unlike terms is called a trinomial. For example, all these terms are trinomial. Algebraic expressions having four or more unlike terms are called polynomials, right? Now, to find the value of an algebraic expression. For given numerical values of literals, we can obtain the corresponding value of the algebraic expression. The process of replacing the literals by their numerical values is called substitution. Let's do the example. Value of x is given 1, value of y is minus 1, and value of z is 2. So, x cube plus y cube plus z cube plus 3xyz. So, we have to put all these values in this expression. Okay, 1 cube plus minus 1 cube plus 2 cube, okay, plus 3 into 1 into minus 1 into 2. 1 cube is 1 plus minus 1 cube is minus 1 plus 2 cube is 8, because 2 into 2 into 2 is 8. 3 2s are 6, and there is a minus, so minus 6. Okay, so what will be the answer? Plus 1 minus 1, 8 minus 6 is 2. So 2 is the value. Okay. Exercise 12.1. Write the following using numbers, literals, and signs of basic operations. State clearly what each letter represents. The diameter of a circle is twice its radius. Okay, diameter, let the diameter be D, radius be R. Okay, now according to the question, the diameter of a circle is twice its radius. This is the radius and twice. Okay, or you can also write like D is equals to 2 into R. Both are correct, right? Operation on algebraic expressions. Number 1, addition of algebraic expression. The basic principle of addition of algebraic expression is that only like terms can be added, right? Solution, if one egg represents, means this figure represents one egg, then 5 eggs, 3 eggs, that is 5e plus 3e is equals to 80, that is 8 eggs, okay. Now, 4 mangoes means 4m and 3 mangoes means 3m, then 7m total, right. Now, rule for addition. The sum of several like terms is another like term whose coefficient is the sum of the coefficient of the like terms. For example, we have to add 8x, okay, then plus minus 6xy plus 11xy and plus minus 2xy. Okay, all these are like terms, so we will add them up. Okay, so what you can do is 8 minus 6 plus 11 minus 2 right here and xy after the bracket or before bracket. 8 minus 6 is 2. 2 plus 11 is 13 and 13 minus 2 is 11. So, 11xy is the answer. Okay. Number 2, subtraction of algebraic expression. The basic principle of subtraction of algebraic expression is that only like terms can be subtracted. Okay. Positive sign and this represents negative sign, means this square represents positive and circle represents negative signs. Okay. So, 3 coins are taken from 8 coins. That means, how will you write it? You will write it as 8c, that is 8 coins, 8c minus 3 coins, 8c minus 3c, that is 5c. Okay. 8 coins minus 3 coins is equals to 5 coins, that is 5c. Now, rule for subtraction, the difference of 2 like terms is a like term whose numerical coefficient is the difference of the numerical coefficients of the 2 like terms. Okay. Let's do an example. We have to subtract 16ab squared from 24ab square. Okay. 24 minus 16 ab square. 24 minus 16 is 8. 8ab square is the answer. Okay. Exercise 12.2. Add 7x and minus 3x. 7x plus minus 3x. 7x minus 3x is equals to 4x. Right? Use of grouping symbols. When we make operations on 2 or more algebraic expressions, we separate them by symbols of grouping, which are parentheses, braces and square brackets. While simplifying such expressions, we first remove the grouping symbols using the following rules. 1. If a plus sign precedes a symbol of grouping, the grouping symbol may be removed without any change in the sign of the terms. Number 2, if a negative sign precedes a symbol of grouping, the grouping sign may be removed and the sign of each term is changed. Remember this, okay? And number 3, if more than one grouping symbols are present in an expression, we will remove the innermost grouping symbol first and combine the like terms, if any. We continue the process outwards until all brackets have been removed, right? Example 1. 2a square minus 6ab plus 5 plus ab minus 5a square plus 7. We have to simplify this. Okay. Since plus sign precedes the second parenthesis, that means we remove it and write the terms as they are. No need to change these sign. Okay. So, you will write 2a square minus 6ab plus 5 plus ab minus 5a square plus 7. Now, what will we do? We will group like terms. Okay, 2a square these are like terms. Then minus 6ab plus ab plus 5 plus 7. Okay. Okay, 2a square minus 5a square is minus 3a square. 6 and 1, minus 6 plus 1 minus 5ab, and 5 plus 12, 5 plus 7 is what? 12. So, this is the answer. After simplifying, we got. Exercise 12.3. Simplify the following. A minus b minus a minus 2c. Now, there is a negative sign before the parenthesis. Now, sign will change. A minus b plus a plus 2c. Okay. A plus a minus b plus 2c. A plus a, 2a minus b plus 2c. So, this is the answer, right? Learning outcomes. The letters which are used to represent numbers are called literal numbers or simply literals. Number 2, algebra is generalized arithmetic. 3, the literal numbers themselves as well as the combination of literal numbers and numbers obey all the rules of addition, subtraction, multiplication and division of numbers along with the properties of these operations. 4, a combination of numbers including literal numbers connected by the signs of fundamental operations of addition, subtraction, multiplication and division is called an algebraic expression. 5, one or more signs means plus or negative separate an expression into several parts. Each part along with its sign is called a term of the expression. 6, an expression which contains one term is called a monomial, which contains two terms is a binomial, and which contains three terms is a trinomial. 7, the terms having same literal factors are called like or similar terms. 8, the terms not having same literal factors are called unlike or dissimilar terms. 9, the sum or difference of two like terms is another like term whose coefficient is the sum or difference of coefficient of those like terms. 10, in adding or subtracting algebraic expressions, we collect different groups of like terms and find the sum or difference of like terms in each group. 11, a symbol having a fixed numerical value is called a constant. 12, to subtract an expression from another, we change the sign from positive to negative and from negative to positive of each term of the expression to be subtracted and then add the two expressions. 13, where a grouping symbol preceded by a negative sign is removed or inserted, then the sign of each term of the corresponding expression is changed from plus to minus and from minus to plus. Remember this, okay? In a raised to the power 5, we call a as the base and 5 as exponent index. And 15, a symbol which takes on various numerical values is called a value. Students, here comes the end of this chapter. Now you will do practice of this chapter.